Okay, so as I said, good afternoon, everybody. So today what I want to do is I'm going to start our final topic of the class called confidence interval, or final section of the class, excuse me, um, which is about statistical inference, which holds two parts to it, but I'll get to that in a second. Your homework number 6 is now posted in the classroom. So if you go to the classroom under homeworks, homework number 6 is posted. So it's not due for a while. It's due Tuesday, the 27th. The syllabus originally had it scheduled to be due on the 22nd. But just because I canceled class one day, I'm going to move the due date to the 27th. Okay. So it's posted here. You can download it, take a look at it. You have a while to complete it. But you should be able to complete at least problem number 1 on the homework after class today. And I highly encourage you to do that. Okay. Just take the 5 minutes to do problem number 1. It'll take, if you pay attention in class today, you'll get a lot out of class. So you should be able to do it even quicker than that. And then the home stretch. Then we have homework number 7 and exam number 4 is going to be on Thursday, 5/06. And that's like 3 weeks away. And that's the end of the class. Is that crazy that we only have 3 weeks of class left?
Yeah. Time flies.
Time super flies, right? Like I can't believe it felt like it felt like we just started this semester. I don't know where it went, right? But anyways,
finishing each other's.
I'm sorry, say that again.
I said it's almost as if we're almost finishing each other's.
Yes, sentences. Yes. Yes. Thank you for the joke there, Melissa. I appreciate it. And just one last thing. I don't know if you guys have seen or gotten emails about the colleges doing vaccine appointments. So I just thought I would plug that. If you're having trouble getting vaccine appointments, I encourage everybody to get it. The college has them on campus. You get the Moderna shot. So, if you haven't gotten it, you should get it. The only thing I will say is the reason I canceled class last time, I went for my second shot and whew, boy, did it knocked me out for a good at least 12, 20 hours. I had a hard time with it. My wife, no problem whatsoever. She was just like, oh, I feel a little tired. Me, I was like, I couldn't get out of bed for half a day. It was crazy. Yeah, first dose was not too bad. I got the Pfizer one. I went to one of the mega sites here in New Jersey, which was like a really weird experience, but awesome because it was run by the National Guard. And it was kind of just like, there were like 1,000 people in there at a time getting vaccinated. It was crazy. But so anyways, I just wanted to tell you, if you're interested in a vaccine appointment, WCC has them.
Thank you.
Yeah, no problem. And if anybody doesn't know the information or anything like that, shoot me a private email and I'll forward you the link if you didn't get it in your own email. Okay. Before I begin our final section of the class, does anybody have any questions about anything? All right. So we're actually moving into our last section of the class. So this was section number 5 that's listed in the syllabus. And this section is about what's called statistical inference. All right. And this statistical inference section here is broken up into 2 parts. Okay. The first is confidence intervals. Okay, that's what we'll do today and then next week. And then hypothesis testing. All right, that's our last topic of the class, hypothesis testing. And we're going to rely very, very heavily on our graphing calculator for these. So it doesn't matter if you have the TI-83 or TI-84 today. I'm going to, it's actually one of those rare instances, excuse me, when you load up the calculator and press the options, it doesn't matter if you're the TI-83 or the TI-84, it looks exactly the same. So I'm just going to have the TI-84 loaded up today. But if you have your TI-83, it's not a big deal. Okay, it's going to be the same look and feel to it. All right, so confidence intervals. So this lecture here, this first lecture is about constructing confidence intervals, and this is for a population mean. Okay. So just recall that the notation for a population mean is this Greek letter mu. Okay, that's what's called a parameter. Right? When the population standard deviation. So does anybody remember what Greek letter we use for the population standard deviation? Just out of curiosity, anybody remember the Greek letter? Looked like this. Okay, so this is the Greek letter sigma. All right, and this is the Greek letter mu. All right, so for whatever reason, this population standard deviation, which is also called a parameter, is known. Okay. So the way I'm going to do confidence intervals in this class is I'm going to introduce just examples with them, and then we're going to let our examples drive the theory. Okay, so today's class is not a big class on theory. There will be some theory I will talk about and some definitions, but it's primarily going to be example driven. Okay, so I want to construct this thing called a confidence interval, and I'll explain what that is. For some unknown population mean, when for some reason you're given the population standard deviation. Okay, everybody okay if I go to the next slide? Everybody can hear me, right? Still? Bueller?
Yes, we can.
Okay.
And that's an amazing movie.
Yeah. When I was a kid, it was whenever I would miss school, I would always watch that, and The Price is Right. So, okay. So why do we need confidence intervals? Okay, and what exactly are they? All right, so suppose for whatever reason you wanted to estimate the mean age of the civilian labor force. Okay, so what we want to do is we want to estimate, okay, this value mu. Okay, so what mu is, it's the mean age of civilian labor force. Right, we don't want to just as a sidebar here. We say the civilian labor force because if you look at the military labor force, it skews younger. So we just want to estimate the average age of the civilian labor force. So what I'm saying here is this mean is unknown. Okay. Okay, I don't know what the average age of the civilian labor force is. Okay, but for some reason, okay, it's given that the population standard deviation sigma is 12.1 years. Okay. So you're given, for whatever reason, that the standard deviation for age of the civilian labor force is 12.1 years. All right, so imagine let's just say that you get a job out of college and you're working for I don't know, the Census Bureau or something, or the Labor Department. And they're like, all right, go estimate the average age of the civilian labor force. It's like, well, how would you do it? Okay. If that was your task. Well, if you wanted to estimate the mean, what you do is you'd collect a sample of data. Okay. So you collect a random sample of data. Okay. And so over here, let's imagine that I did this. This is the sample age of 30 people in the civilian labor force. So these are the ages of 30 people in the labor force. And so what happened is you call these 30 people and you say, how old are you? How old are you? How old are you? How old are you? Are you working? Yes. Okay. How old are you? And you found that the sample mean X bar is equal to 41.3 years old. Okay. So let me ask everybody here a question, okay, and use the chat to think of this. Do you think that the average age of the entire civilian labor force is exactly 41.3 years old? Like, do you think that the mean age of it? Okay, awesome, right there in the chat there, right? So, like, why would you guys say, Jamie and Storm? Why would you say no? That the average, you're absolutely right, but why is the average age not exactly 41.3 years?
I honestly think it's too high of a number.
Okay, it may or may not be. I don't even know what the mean age is, but like this.
There will be varying means.
Okay. I kind of like that. All right, Jamie had a reason, but I was thinking. All right, so here's the whole thing. If you call just 30 people, okay, I mean, in the civilian labor force in the United States, there's probably over 100 million people, okay, who are in the civilian labor force, and now you're just calling 30 people, okay, and there's like no way that the mean of just 30 people is exactly the same as the mean of all 100 million people in the civilian labor force, okay. So here's the thing. This is a great estimate for mu. But probably not the real value of mu. Or exact value of mu. And here's another way you can think about it. Like if you call 30 different people, are you going to get a different sample mean probably? Like, yeah. Yeah. And if you call another 30 people, you'll get a different sample mean. So it's like, this is just the mean from 30 people. Okay. So there's no way it can be the actual real mean of everybody in the civilian labor force. Okay. And that's okay. And that's okay. Like all we're trying to do is estimate it, get a value that's like close to it. Is everybody okay if I go to the next slide? Sorry, you guys hear my like soda here clanking as I'm lecturing? Just hear that? Sorry about that. I'm trying to cut back on the coffee and switching to diet soda, which is probably less healthy, but whatever. Okay. So here's the deal. The value of X bar is equal to 41.3 isn't the actual real population value. Okay. It's probably close to the real value though. Okay. But it's not the real value. Okay. Why? Because it's just a value from a random sample. So a value of a random sample of 30 people. Okay, this, what we call a single value estimate is what's called a point estimate. And all a point estimate is, it's a single value used to estimate a population parameter, okay? So what we're saying here is X bar is the point estimate for mu. It's the single value estimate for the population mean. Okay, so what is the real value of the civilian labor force? Okay, what is the real value of mean? Okay, that's what I'm asking. So here's a question for everyone. Do you think it's possible for even the government in the United States to know what the real mean age is of everybody who's in the civilian labor force? Do you think it's possible? Like, do you think there's a database out there of every worker and their exact age? Yeah, like as much as you would like to think that like we have that good data, like there's just no way. There is not. Okay. There's no database of everybody who's employed in their mean age and their age and be able to figure out their average age. So here's the deal. I know this is why it seems weird. We actually can never know the real value. Okay. We could never figure out the average mean age of the civilian labor force. Like there's just no way. Okay. So we recognize that problem. Okay. That like, hey, look, this is not the real value. There's no way I could know what the real value is. So how might like I get a better way to figure out what the real value could be? So we use this thing called a confidence interval to find it or to estimate it. And all a confidence interval is, it's a range of values used to estimate the value of a population parameter. Okay, so instead of being a point estimate, a confidence interval is what's called an interval estimate. Okay, so it's a range of values. And what I mean by a range of values is it has what we call a lower bound, a lower value, all the way to an upper value or an upper bound. All right, is everybody okay if I so let me, before I go to the next slide, let me just say what's going on here. Like I can't know the real value of the population mean. Okay, I know my point estimate, my sample mean is a good estimate, but not the real value. I can't know what the real value is. So what are some plausible values that the real value could take on? So we use what's this thing called an interval estimate. And trust me, after you see the first, after I like work the first example, it'll make sense. And like, I know I say this all the time, but don't you guys feel that way in this class? Like I'll lecture and I'll be like, I kind of understand what's going on, but not really. And then after I show you the first example, it kind of hits home.
Yes, that happens.
It happens, yeah.
You get the big oh.
Or like, okay, I kind of see what you're finally talking about here, Matt.
Yeah.
Okay. Yep. And just stick with me for this. Okay. So what exactly is an interval estimate then? So going back, what is this range of values used to estimate a population parameter? Okay. So an interval estimate is called a confidence interval. So there's two words here. This word confidence and interval. Okay. So we know what an interval is. It's a range of values. And think of confidence as how sure you are. Or so how sure you are correct. Okay, so confidence intervals are range estimates with what we call a given level of confidence listed as this. Okay, so the level of confidence is 1 minus alpha, and I'll explain what alpha is, times 100%. Okay, so when I say confidence intervals, you're going to hear me say things like, I want to be 90% confident, or 95% confident, or 99% confident. So alpha is what's called the level of significance. Okay. So I know this seems weird, but think of alpha as how often you will be wrong. Okay. So for example, if I say I want to construct a 95% confidence interval. Okay. So I want to be 95% confident in my results. Okay. How often am I going to be wrong? If I'm going to be right 95% of the time. I'll be wrong 5% of the time. Yeah. So in this case, we write it as a decimal. So a 95% confidence interval. It's 1 minus alpha. So I'll be wrong 5% of the time times 100%. So 1 minus 0.05 is 0.95 times 100%. This is how we get that 95%. Okay. So just think of alpha as how often I'm going to be wrong. So for example, if I say I want to be 90% confident, 90% confident, how often am I going to be wrong? I'm going to be right 90% of the time. So if I'm 90% confident in my results, I'll be wrong. Yep. 10% of the time. Thanks, Bertha. Yep. How about if I'm 99% confident? How often will I be wrong? Yep. Awesome. Okay. So what do I mean by when I say how often I'll be wrong? Like, okay, I'll be wrong 1% of the time, but like, what does that mean? What does it mean to be wrong? Okay. All right. So suppose that the real mean for the civilian labor force is 42 years old. Okay. So just suppose. Now, again, there's no way I can know that, but let's just suppose this is what it is. Okay. So again, we can't really know this, but just assume it. Okay. Just assume that the real age of the civilian labor force is 42 years old. All right. So if we collected a sample of size 30 100 times, okay, so we have 100 different samples. So 100 different samples. And we constructed what we call 95% confidence intervals for the mean. We would be right, and I'll put it in quotations, 95 times out of 100. Okay, so what does it mean to be right? So look at this first interval I construct here. So interval 1. So I take my first sample and I say, hey, look, I'm 95% confident that the mean age of the labor force, okay, the mean age of the labor force is somewhere between 40 years and 48 years. So remember, the real mean is 42. So does 42 fall in my interval? Is it somewhere between 40 and 48? Does 42 fall between 40 and 48?
Yeah.
Yeah. Okay. That's what it means to be correct. Okay. But now look at this next one. Okay. If I take a sample and I construct an interval and I say, hey, look, I'm 95% confident that the mean age of the labor force is between 43 and 51, but the real mean is 42. Did I get it right or did I get it wrong?
Wrong.
Yeah, it's wrong because 42 is not really in there. So what this is saying is, look, if you do this 100 times and you want to construct what we call 95% confidence intervals, that means you'll get it right 95 times out of 100. Okay, so 95 times you'll be correct. Five times you'll be incorrect. And generally what happens when you're incorrect, it's just because the sample you collected did not accurately describe the population. And there's nothing you really could do about that. So this is why I love statistics more than any other branch of mathematics. Like when you solve an algebra problem, like you just get the right answer and that's it, you know? Like the process I'm going to show you in these classes, like for a 95% confidence interval, it's like, yeah, you know, I'm going to be right 95 times out of 100, but I'm still going to be wrong 5 times out of 100. And like, that's just statistics. That's just the nature of data. Okay. So what I want to show you now So next, what I'm going to show you is how do we construct these confidence intervals? Okay, that's what I want to show you. Like I just made these intervals up here, okay? But like what I want to show you next is like how you actually construct it. All right. Let me know if it's okay for me to go to the next slide. If I don't hear anything, I'll assume it's okay.
Can you not see reactions?
I mean,
No, like about
like you got,
the video being on, like there's like a reactions thing where it's like emojis. You can
oh, I can do that. But that seems like right there. I got a little thumb up. Okay, I appreciate that. I'm not hip as maybe some of your other instructors are. I'll have to get better on that next semester. So I'll just drink my soda and just hopefully you guys are all with me. Just out of curiosity, do a lot of your professors use the emoji thing?
And not really.
Some do, some do.
Sometimes I just do it if I really don't want to say anything in chat or without the microphone. So I think thumbs up is really, really helpful.
Okay. I don't know if you guys all heard, but some classes are going to be in person next semester. So there will be some remote, some in person. So, if you don't like, this remote stuff, you can find a in-person class. Well, I don't know which ones, and it's very limited right now, but like everything's changing, right? Like if everybody gets vaccinated, maybe COVID will eventually go away, so I don't, in March, I thought the world was going to end. And then by April, I'm vaccinated and all my friends are, so like, I can't even tell you what September is going to be like, so all I know is right now we're planning to have some classes back in person, some not. Okay. Well, I'm glad, if you want to take classes in person, that's great, so there'll be that opportunity. And then what's really good, and before I go on, just to talk about this a little bit more, but what's really great is they'll all be like smaller class sizes. So you'll get better interaction with the professor, I believe. So it's a good thing. Okay. So confidence intervals, how you construct them. Okay. Confidence intervals for a population mean are always of this form. You take your point estimate. Okay. So what was our point estimate? Our point estimate again was the sample mean. So you take your sample mean that you found, and I'm going to go back a few slides just for a second. Like we take our sample mean here, this X bar is 41.3. We say, okay, we know that's a good starting point, but it's not the real value. So we're going to start with our point estimate, X bar. And then we're going to add and subtract. That's what this plus or minus means. Okay, we're going to add and also subtract away from our point estimate, this thing we call the margin of error. Okay. How many people, just out of curiosity, have seen the term margin of error before? Like maybe in the news or in the newspaper, like when you look at a political poll or something. So Storm has, great. Anybody else has seen it before? It's okay if you haven't. Generally you've seen it before if like you look in the news and I always hate to say political polls, but that's just like where it's most common. But you'll see something like they'll say, "Oh, the president's approval rating is, based on this poll from, wherever. President's approval rating is, 55% or whatever it is. I don't know what Biden's is right now, but And then if you look in the bottom corner, it'll always say margin of error plus or minus 3%. Like I'm going to show you how to calculate that in this course. It's just not just a made up number. Okay, so the margin of error of a confidence interval is a measure of how accurate the point estimate is. Okay, so if you have a large margin of error, it means your point estimate isn't very accurate. And if you have a very small margin of error, it means, wow, your point estimate is really accurate. Okay. So generally what makes a point estimate accurate? I'm going to say what helps make it accurate. And generally what it really comes down to is a larger sample size. Okay, obviously the more data you collect, the more accurate your point estimate is. So like a sample size of 100 is better than a sample size of 50. That's what's going to impact your margin of error. Okay, so the margin of error depends on 3 factors. As I said, the sample size, this is the most important. Yep. Oh, sorry, Alexander. Yeah, of course I can go back. Sorry, I went a little fast there.
Professor, what's on the very bottom after it says point estimate accurate?
What helps make the point estimate accurate, and then it's larger sample size.
Thank you.
Yep, no problem. Okay. Okay, so the margin of error depends on 3 factors. What we call the level of confidence. I'll come back to that. The sample size. Okay, this is the most important. And the standard deviation of the population. Okay. So as the level of confidence increases, so if you want to be more confident in your result, the margin of error also increases. Okay, so margin of error is larger for 99% confidence intervals. So I'm just going to put CI, confidence intervals, then 95% confidence intervals. Okay, so when you increase the margin of the level of confidence, you want to be more confident in your result. Your margin of error just gets bigger. All right, the sample size impacts it. So as the size of the random sample increases, the margin of error decreases. Okay, so larger sample sizes decrease margin of error. Okay, and then the standard deviation of population. So obviously, if there's more spread in the population, the wider the interval will be for any given level of confidence. So basically what's going on here is your margin of error is made up of 3 things. Okay, when we're going to calculate a margin of error. Okay, so the calculation depends on 3 things. The level of confidence, the sample size, and the standard deviation. So all 3 of these things are going to be in the formula I give you to calculate. Okay, you're going to need all 3 of these things. Okay. Everybody okay if I go to the next slide? Okay. One sec. Yep, no problem. Of course. Okay. Yeah, thanks. All right, so in the following lectures, we'll learn how to construct these confidence intervals for a population mean, okay? And so this is for the population mean mu. Okay, so we're gonna learn 2 types. So this is today, and then the next type we'll probably get to, we'll start today, and then also finish next Tuesday. So today and / next Tuesday. The first is a confidence interval for population mean when the standard deviation is known. So sigma is known. Okay. And the second is a confidence interval for a population mean when with the population standard deviation is unknown. So sigma is unknown. This is more how it's done in the real world. Okay. What we do today just kind of sets up confidence intervals. Like in the real world, you often won't know what the population standard deviation is. So today's lecture is more kind of like just setting up confidence intervals. And then next class, you'll see how it's done in the real world. Okay. This second part is also going to introduce a new statistical table. So I'm going to teach you how to read a new statistical table just once or twice, but then I'm actually going to just switch to the calculator. So just like when we were doing the standard normal table, I'll show you what it looks like, how to read it, and then we'll go right to the calculator. Okay. Everybody ready for the next slide? Okay. All right, so how do you construct these confidence intervals? Okay, you're going to need a formula. Okay. So these confidence intervals are a range of values, okay? So what this range of values means is there's a lower bound, what we call a lower bound and an upper bound, okay? And just so we're clear, it includes all the values in between. Okay, so these confidence intervals, what they say is look, I'm going to estimate this population mean with a range of values, and it's saying the mean could take on any value between this lower bound and this upper bound. So anything in between. All right, so our formula is you take the point estimate and you add and subtract the margin of error. Okay. So the point estimate is the sample mean. The margin of error is made up of, it is three things, but you'll only see two things listed here, okay? It's a critical value times what we call the standard error, okay? And have you heard me use the term standard error before in this class? I have. The answer is yes. So I've used the standard error. What the standard error is, it's the standard deviation for the sampling distribution of the sample mean. And there's a very simple formula for it. Okay. So this is the formula we're going to use. We're going to take our sample mean and we're going to add and subtract this thing called a critical value. Okay. And this critical value looks like this. It's Z with the subscripted alpha divided by 2. Okay. And this alpha comes from, remember, my alpha is my willingness to be wrong. So this comes from, and let me just go back real quick. This comes from the level of confidence. So that's how you're going to use the level of confidence. Okay, so this is new, this critical value, Z of alpha divided by 2. This is new. Okay, but I'm going to show you how to find it very, very easily. Times the standard error. Okay, and the standard error is you just take the population standard deviation and divide it by the square root of n, okay, where the square root of the sample size. Okay, so Z of alpha is what we call a Z critical value. And let me just write this here. Sorry about this. I should have included this in here. Sigma is the population standard deviation, so that will be given. And n is the sample size. Well, how do you find this Z of alpha critical table? or Z, this Z sub alpha divided by 2, this Z critical value, you can look it up on this table. Okay. Had we been in person, I would have shown you how to find all these values by hand on the standard normal table, but I just want to focus more on examples for this class. So you're just going to look it up here. So for example, when I say, if I want to compute a 90% confidence interval, my Z of alpha divided by 2 would just be 1.645. You say, okay, Matt wanted a 90% confidence interval. I'm going to use this critical value. If I wanted to be 95% confident in my results, what is the corresponding critical value for that?
$1.960.
Yep, that's it. That's it. So all these critical values come from the standard normal table, okay? And you're just going to take that and you're going to multiply it by the standard error, and that's going to give you the margin of error. All right. And so believe it or not, this is actually an incredibly easy formula to follow. Okay. Might look complex, but actually super easy. Okay. So before we take our break, what I just want to do is I just want to walk you through one example really, really quickly. Okay. Everybody okay if I go to the next slide? All right, I hope so. Okay, so let's do an example. So we're going to go back to how we started this class, okay? In a sample of 30 individuals in the civilian labor force, it was found that the sample mean was 41.3 years. So again, this sample mean here, this is our point estimate. Okay, it's like a good starting point, but it's probably not the real value. Next, it says assume the population standard deviation is 12.1 years. So n is equal to 30, x bar is equal to 41.3, and sigma is equal to 12.1. So look, n, x bar, and sigma. X bar, sigma, and n. They're given in your formula here. So next it says construct, and I'll talk about how we interpret. Construct and interpret a 95% confidence interval for the mean age of the civilian labor force. Well, look, 95% confident. That means my critical value is 1.960. So that replaces this value in the formula right there. And then you have all four parts, and it becomes just a plug and chug through the answer part. Okay. So construct and interpret a 95% confidence interval for the mean. So here's how you do it. So to construct a confidence interval in this class, we're always going to use this formula, okay? And look, you were given in the problem, x bar was equal to 41.3, sigma was equal to 12.1, and n was equal to 30. So you just need to figure out z of alpha divided by 2. So if you want to be 95% confident, okay, that's what it says, 95% confident. What is the z critical value again that I'm going to pick from this table?
$1.960.
1.960. Boom. 95% confident. Boom. 1.960. So look, then you're just going to replace it in your calculator here like this. So everybody grab your trusty calculator with me. All right. It's worth it just to practice along here. All right, so look, when you go to do this by hand, you're going to do the margin of error first. So you're going to take 1.960 times 12.1 divided by the square root of 30. If you followed along, how many people got this right here? 4.329929391. Okay, awesome. Yeah. So I'm just gonna take this to one decimal point. Okay, I'm just gonna say 4.3. Okay. So you always have to find your margin. When doing this by hand, find margin of error first. So we did that and we got 4.3. So what you have to now do is you have to do this plus minus means do both addition, subtraction. Okay, so the lower bound here, you take your point estimate, 41.3, and you subtract 4.3. So when you do that, 41.3 minus 4.3, you get 37.0. And now the upper bound is the addition part. Okay, so you take 41.3 plus 4.3, and you get 45.6. Okay. So this is just the construction part. Okay, we're saying we're 95% confident that it's somewhere between 37 years old and 45.6. Okay. So now you have to interpret this. Okay. And this is the most important part. Like, what does this mean here? Okay. And this is the interpretation. We were trying to estimate the mean age. Okay. So just recall, we're estimating the mean age. The mean age of labor force. So we'd say this, based on this sample, we are 95% confident, okay, that the mean age, okay, the mean age of the civilian labor force, again, we can't actually know what the real value is. Okay, there's no way I can call all 100 million people, 100 million plus people in the civilian labor force. So I'm saying, look, based on this sample, we are 95% confident the mean age, it's somewhere between. It's somewhere between. It could be as low as 37 years old, okay? Or the mean age could be as high as 45.6 years, and all values in between. That's what's going on here, okay? Well, let me ask you this before we take a break. Was the construction of the confidence interval pretty easy, at least? Formula not too bad now that you've seen me do it once?
Not bad.
Don't worry, all we're gonna do the rest of the class is just more examples, okay? So I'll make sure that it makes sense for you, okay? Wow, can you guys believe that I've been talking for 50 minutes? I hope that went fast for you all. Went fast for me.
Yeah, it went pretty fast.
So let's take a 10-minute break. We'll start back at 2 o'clock. All right. Before I go on break, any questions? All right. I'll see everybody back in 10 minutes. Enjoy your break. Maybe go outside or something for 10 minutes, but I'll see you at 2 o'clock. All right. Everybody can hear me?
Yes.
All right. So for the second half of class here, sorry, my chair. I don't know if you guys can hear my chair. It's very squeaky, but for the second half of class here, everybody take out and have handy their graphing calculator here. Okay. Your TI-83. It doesn't matter if you have a TI-83 or TI-84. It really doesn't matter. The good news is, looking back at these, where was I? Yeah, looking back at these formulas here, your calculator will actually do this for you, which is a phenomenal thing. And I think, as I don't know, I'm struggling to say this correctly, but I think it's great to learn how to use all these formulas and everything. But you guys find that just like when you can use the calculator, it really helps and it really prevents you from making mistakes. Like I thought, like for the last exam, like the normal CDF was just phenomenal for helping us tackle these problems, right? So you can also do this with your calculator, okay? And on homework and exams, I highly suggest use your calculator. Okay, it'll just really prevent you from making mistakes. All right, so in your calculator, if you want to construct confidence intervals, okay, everybody grab your calculator, your trusty calculator in your hand, and you're going to hit the stat button, okay? So when you hit the stat button, scroll over to this test. Okay. How many people see on their screen something that looks like what I have on my calculator there? How many people got? How many people are with me on that at least? Okay. Do you remember this was all about constructing confidence intervals? Do you guys see here the word interval right here? How many people see this number 7? Okay. Yeah. If you scroll down a little bit, you see something. 7 says Z interval, 8 says T interval. And if you scroll down even more, you'll see these other things called 2 sample Z int, 2 sample T int, 1 prop Z int, and 2 prop Z int. We're going to be using in the coming weeks or coming lectures, this lecture is in the coming one. I'm going to show you today number 7. Next class on Tuesday, I'm going to show you number 8, when we're going to use number 8. And also next Tuesday into next Thursday, I'm also going to show you letter A here. Use this 1 dash prop Z int, okay? All right, so for our purposes, you see this Z part here, this Z? The Z corresponds to the critical value, okay? So you use Z interval because your critical value was Z of alpha divided by 2. See the Z? Like the Z tells us that we're going to use this Z interval. So go to Z interval, number 7, and hit enter. Okay. Now, how many people see this on their computer, on their calculator with me? Anybody see it with me? Yep. Okay.
I'm sorry, what did you press again?
Yeah, no problem. So you're going to press the stat button. Then you're going to scroll over to tests. And then you're going to scroll down to number 7, this Z interval. Okay. And then you should see something like this. Okay. There's two things up at the top. It says input. It says data or stats. Now, if you have the raw data, okay, you can plug that into your calculator, and we're going to do examples with that later. But what we have here is whenever I tell you what the mean and the standard deviation is, you're just going to scroll over to stats. Okay, so everybody scroll over to stats and then hit enter. And you should see something like this. All right, how many people see that on their screen with me? Great. Good. So look, let's just go back and redo the previous problem, okay? So this is the using the calculator for the previous problem. On your input screen here, okay, you see sigma, x bar, and n, okay? So what you're gonna plug in there is sigma is the population standard deviation. X bar is the sample mean. And n is the sample size. So for our previous problem, so scroll down. I told you that the standard deviation for labor force was 12.1 years. The sample mean that we got was 41.3 years. And does anybody remember how many people we talked to, what the sample size was?
30.
Mm-hmm. And then you see this thing next, it says sea level. That's the confidence level. So I wanted a 95% confidence level. So it's always going to default to 0.95. Okay. So if I want like a 99, you would just have to change this, but you always have to change it to a decimal. You can't put like 95 for confidence level here. Okay. You have to put 0.95. And then scroll down and hit calculate. How many people see this on their screen? Okay.
Professor, mine, I am not, I didn't get it on my calculator.
So did you go, let's go back. Did you go stat?
Yes, on my input, I have input data stats, but I have mule.
Hold on. So you got to scroll over to stats.
Yes, I have that.
And you hit enter.
Right.
So
But before that, I have the mule sign and it says 0. It didn't go straight to that one.
I don't understand. I'm sorry. I don't understand. You want me to go to where?
No, I am at Z test, right?
No, Z interval.
Z interval. Okay, let me then start it all over then.
Yeah, go to stats, tests.
Start and then go to tests.
And then you want number 7. Z interval. And then you scroll over to stats and you input all these numbers.
Number 7.
Number 7. Yep. Well,
Okay, I got it now.
Good. Boom. Okay.
Thank you.
Yeah, of course. And you got this same thing here then.
12.1.
So let's look, okay? Look at my confidence interval. This is what I had when I did by hand. I have 36.97. Over here, I have 37.0 just because I rounded. And over here, I have 45.63. Here I have 45.6. Okay. What do you think? Was the calculator pretty easy to do it?
Yeah, much easier.
Yeah. So the calculator will solve this instead of doing the do the calculations by hand. Okay. So I generally find that what's going to happen is with these problems is like it just comes down to figuring out like what information you're giving and how to correctly plug it into the calculator. And then once you do that, like the calculator just goes do, 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 and it'll spit out the answer for you. Okay. So what I want to do with the time that we have left is I just want to do basically 2 more examples with you. Just so, and we'll do some of it by hand and some of it with the calculator, just so you can see the difference with them. Okay. Everybody okay if I go to the next slide? Okay, I hope so. All right, so here's example 2, okay? So calcium is the most abundant mineral in the human body and has several important functions. So I didn't know that. I didn't know calcium was the most abundant. Huh. So most of the body calcium is stored in bones and teeth. Okay, yeah, that makes sense. All right, where it functions to support their structure. Okay. Recommendations for calcium are provided in this dietary reference intakes. Okay, this is developed by the Institute of Medicine of the National Academy of Sciences. Okay, so what it says is the recommended adequate intake, okay, for calcium. So the RAI, the recommended adequate intake, okay, for calcium, and this is for adults ages 19 to 50, is it saying, look, you should be taking 100 milligrams of calcium a day. Okay. Which makes me think I should not be drinking my not be drinking this. If you guys can see my video, I should not be drinking my Pepsi Zero right now. Maybe I should be drinking my more milk. But anyways, all right. So a random sample of 18 adults. So look right there, 18. Okay, that's your sample size. Okay, with incomes below the poverty level, gave the following calcium intakes daily. Okay, so basically this data came from a study that was looking to investigate if, unfortunately, people who live below the poverty level just consume less milk daily than the recommended adequate intake. Okay, so they sampled these people, all right, these individuals, and they asked them, hey, just record how much calcium or how much, milk you drink a day. And this was their results. Okay, so right here from this data, I'm saying the sample mean of these 18 adults is 947.4 milligrams. Okay, and let's assume the population standard deviation for daily calcium intake, sigma, is 188 milligrams. Okay, so look, let's just talk about what's given. Okay. From this sample, how many adults did we talk to? How many people?
18.
18. Yep. What's my X bar from the sample?
947.4.
Oops. 947.4 milligrams. Yep. And look, they give you the standard deviation sigma. It's 188 milligrams. So basically what you're going to be doing now is when you're given those things, it's like, oh, great, phenomenal. Now I can construct confidence in this. Okay. So when you do these problems, there's 2 ways that it's going to happen. Okay. You're going to be given these, or you'll see in the coming lectures, I won't do one today, but later on, or you'll be given the raw data, which we actually have over here, which is fine. But we're just going to go with what's given. All right, is everybody okay if I go to the next slide? Okay. So here's the first question. Let's construct and interpret a 90% confidence interval for the mean calcium intake mu of all adults with incomes below the poverty level. Okay. So at this point, what you have to do is you have to recall the formula for confidence intervals. So I'm going to put formula for CI. It's X bar, add and subtract our critical value, Z of alpha divided by 2, times sigma over the square root of n. But look, check this out. X bar is given, sigma's given, and N is given. Okay? So the first thing we're going to do is we're going to construct it. So we're going to do this one by hand, and then we'll do the next one in the graphing calculator. Okay. So X bar, all right. Somebody help me out. It's on the previous slide. What was the average intake of calcium for these individuals? Was it
947.4.
Okay, then we need to add and subtract. So look, here, I want a 90% confidence interval. Okay, 90% confidence interval. So let me scroll back to the table. Where are you, table? Come on. Here you are. So what is the Z critical value for a 90% confidence interval? When you look at this table, what is it? Thank you, Bertha. Yep, which is 90% confidence, boom, 1.645. So plus or minus, this Z of alpha divided by 2 just gets replaced with 1.645 times the standard deviation, which was 188, divided by the square root of 18. All right, everybody grab your trusty calculator. So you're going to do this margin of error, okay? So you're going to go 1.645 times 188 divided by the square root of 18. How many people got this right here? Just for confirmation. Storm, boom. Anybody else? Okay. So I'll just go 2 decimal places. Awesome. Thanks, everybody. 72.89. Oh gosh, why do I have such a bad memory? 72.89. Okay. So what that means is the lower bound of the confidence interval, you're going to take 947.4 and you're going to subtract 72.89. And you get 874.51. And then the upper bound, you're going to add. So it's 947.4 plus 72.89. And you get 1,020.29. Okay, so that's just the constructing. Boom. Now the interpretation. And it goes like this. Based on this sample, we are 90% confident the mean calcium intake of all adults with incomes below the poverty line is between 874.51 milligrams and 1020.29 milligrams daily. And that's it. It's like, okay, look, we don't know what the real mean is, okay, of adults with incomes below the poverty line. But what we can say is, look, I took this sample, and based on this sample, I'm 90% confident, okay, that their mean daily intake is somewhere between 847.51 milligrams and 1020.29 milligrams daily. Okay. What do you think? Not too bad? I can't tell with everybody's silence. Not too bad, but okay, that's fair. That Alexander, that's a fair response. All right, let's switch to the calculator now, okay, and see if the calculator makes this any easier. Okay. So I'm going to change it up in the slides a little bit here. Let's construct and interpret. Let's do a 99%. Okay. 99 instead of 95. Okay. Confidence interval for the mean calcium intake mu of all adults with incomes below the poverty line. Okay. So we're going to use our calculator. Which is this Z interval. All right. So everybody grab your trusty calculator. It never lets you down. Okay. So everybody with your calculator in hand. Hopefully everyone has their calculator in hand. Let's hit the stat button. I'm going to scroll over to tests. And what number was it again?
7.
Yep. You're going to scroll down to Z interval. So Z interval. And now look, you have the stats. So under stats, what you're going to have to do is you're going to have to change this data that was there. Okay. The standard deviation was 188. The sample mean was 947.4. And what was our sample size? How many?
18.
Yep. Thank you. You said it. I cut you off. 18. Okay. And what did I change the confidence level to?
99.
Okay, so what you're going to have to do for this C level, you're going to have to go 0.99. So if it's different from 95, you're going to have to change it. So 0.99. And you're going to go to calculate. All right. How many people got this right here? Okay, Bertha, thank you. Boom. Anybody else? Can only the Storm, thank you. Okay. Yeah, so look, your calculator, instead of us plugging through it by hand, your calculator does it for you right there. So the confidence interval, the lower bound is 833.26. And the upper bound is 1061.5. 1061.5. Okay, so let's interpret this. And look, you can see the standard verbiage, okay, that I've used in the examples, okay? Based on this sample, we are 99% confident the mean calcium intake of all adults with incomes below the poverty line is between, in this case, it's now 833.26 milligrams and 1061.5 milligrams daily. Okay, so let me ask you this question. You've seen the confidence intervals here for both of these. So what happened to the confidence interval as the level of confidence increased? Okay, what I mean by that is, did the confidence interval get wider or narrower as you increased the level of confidence?
It's narrow.
So it went from this 74.51 to, so initially was for a 90% confidence interval was 874 to 1020. But when you went to 99, it went to 833 to 1061. So
that's wider.
Yeah. So as you increase the level of confidence, okay, the interval gets wider. Yeah, that's what happens. Right, so let me ask you this. I'll go on ahead. I cut you off.
Professor, can we go back on the calculator? I got stuck. I didn't get the sample size before this one.
What do you mean?
The N. 18. Okay.
Yep. All right.
And
So
the level was 0.99.
Yep, because we went to a 99.
Okay. All right. Thank you. I got it.
No problem. All right. So let me ask everybody this: is it at least pretty straightforward? Using which is easier, calculator or by hand? Just out of curiosity. What do people think? Calculator or by hand?
I will use the calculator.
I got one for the calculator. Like this stuff done in the real world, nobody does it by hand. They all use technology to use it. So we're going to rely on the calculator for this. You're more than welcome to do it by hand. I just think it creates a little bit extra confusion. All right, so let me show you why an application of confidence intervals and what they can actually tell us. Okay, so I'm going to go back and add a question to this. Okay. So a researcher believes the mean, this RAI, this mean recommended adequate intake, of calcium is less than 1,000 milligrams a day for individuals with incomes below the poverty line. Okay. Do the confidence intervals support his or her belief? So this is the context of the problem, right? So what maybe the researcher says, look, it's people who live below the poverty level. It's really hard, and maybe they don't have the resources to buy milk every day, something like that. Okay, and so it's sad, and he or she wants to test to see if hey, on average, it doesn't look like they're getting the recommended adequate intake daily. Okay, on average of everybody. Okay, because I can tell you right now, unfortunately, I don't think I get the recommended adequate intake. Okay. So my question for you is this. The researcher says, hey, look, I think the mean is below 1,000 milligrams daily. Okay. So look at our confidence intervals. Do our confidence intervals support his or her belief or not support his or her belief? This is where it gets a little tricky. Anybody got a guess? Crickets, right? No guesses? All right, let me go back and write this. Look, this was the 90% confidence interval. It was saying the mean could be anywhere between I'm just going to round it off, 875 to 1020. And the 99% confidence interval was 833 to 1062. Do you guys notice that both confidence intervals go over 1,000? Do you see that 1,000 falls between those confidence intervals there? The Storm sees it. Yep. Does everybody else see that 1,000 falls between those two numbers? So when the researcher says something like, "Look, I think they watch less than or they consume less than 1,000 milligrams daily." Well, I know 1,000 is closer to the top end of the intervals there, but the mean could be 1,000. It could actually, the mean could, in both cases, could actually be more than 1,000 milligrams per day. So our confidence interval says, look, I know you took a sample of these 18 adults and it got 947.4 milligrams, but you know, the real mean could be anywhere between these two numbers. And so the answer is no, the confidence intervals do not support his or her belief. And this is because 1,000 milligram falls in both intervals. So that's one application of these confidence intervals, is to test a belief here. All right. How about one more example for class today? Sound good? Bring it on. Okay. Okay. So here's example 3. All right. According to Nielsen and Co., adults watch an average of 28 hours of TV per week. So what they're saying is adults watch an average of 4 hours of television a day. Okay. Which is a lot, right? Which is crazy. So I want to set this problem up a little bit here. Do you guys think college students in general watch more or less TV on average than the average American, the average adult American? Okay, less. Yeah. Why do you think less, Bertha? Anybody agree? Yeah, you spend more time studying. Maybe you have a part-time job too on top of school. Like, you know, I remember when I was a college student, okay, when I was in my senior year of college, I was taking like 18 credits and had 2 part-time jobs. I had like no time for TV. It was crazy. Okay. Now, you know, I have a kid, but now I'll be honest with you all. When he goes down to sleep at night, as soon as he goes down, I eat dinner and then I go lay in bed and watch TV for like 2 hours because I'm so spent. So I, I watch a lot more TV than I did when I was a college student. Okay. All right. So here's the thing. Our goal here in this problem, see if college students watch less on average. Okay, that's our goal. We want to see if college students watch less TV on average. Okay, so here's what we do. We collect a random sample of 50 college students. Okay, and find the mean hours of TV watched, to be 21 hours a week. Okay. Assume the population standard deviation for hours of TV watched per week is 9 hours. Okay, so assume the hours of TV watched, the standard deviation is 9 hours per week. Okay, let's construct and interpret a 95% confidence interval for the mean mu. So the average, the mean hours of TV watched per week by college students and then the final question is does the confidence interval support the claim that college students watch less than 28 hours of TV per week on average? Okay. Whew, seems like a lot. Okay. And my wrist is starting to hurt from all this writing. Okay. Anybody else's wrist? I'm sorry?
I said same here.
Yeah.
Especially because I'm a lefty. My hand hooks a little bit.
Oh, my wife is a lefty. We actually think my son is a lefty. I hope so. Being a lefty is cool.
Lefties are cool.
They are. I'm kind of jealous that I'm not a lefty, to be honest with you. It's like a cool little feature. It's like a club, like left-handed people are like, oh yeah, I'm a lefty. And I'm just not in that club, and sometimes it's sad. Okay.
I'm ambidextrous.
I'm not. I cannot do anything with my left hand. I can barely lift up a cup with my left hand. So that ship has sailed. But anyways, let's go back to the problem. So I just wanted to give people enough time to write it down. Is everybody okay if I go to the next slide?
I really don't understand the last question, even from the previous.
I'm gonna explain it. Okay.
Thank you.
Yeah. I'm gonna answer it when we get there. Okay. All right. So let me just go to the next slide and let's just start with what's given. Okay. How many college students did we talk to? What did I say the sample size was? I think it was 50, right?
Yes, 50.
Yep. And on average, how many hours a week did those college students spend watching TV?
21.
Mhm. And what did I say the standard deviation was? Was it 9 hours a week?
9 hours, you said 9.
Okay. So that's just the information given. So the first question says, construct and interpret a 95% confidence interval. Okay. 95% confidence interval. Well, the good news is we're going to use our calculator for this. Okay, so everybody grab their trusty calculator. So what you're going to do is you're going to press the stat button. You're going to scroll over to tests. And it's number 7, Z interval. 7 Z interval. So under stats, you're just going to have to change this. The standard deviation was 9. X bar was 21. We talked to 50 college students. And I want the confidence level. I asked for 95. So I'm going to change it to 0.95. When you do that, you get this. Okay. How many people have this on their screen right here? 18. You're good? We got one yes. So 18.505 to 23.495. Okay, good. Got a few yes. So my calculator just told me what the confidence interval was. So the way you interpret this, based on this sample, we are 95% confident that the mean hours of TV watched per week by college students is between 18.505 hours and 23.495 hours. So look, I don't know what the real mean of college students is, okay? But I'm saying, look, I took this sample and I'm 95% sure that the real mean time that college students spend watching TV per week, it's somewhere between 18.505 hours and 23.495 hours. So look, the next question was this: does this interval support the claim that college students watch less than 28 hours per week on average? What does everyone think? Does my interval support the claim that, hey, look, college students are super busy. On average, they're not watching as much TV as a typical adult like Matt? What do you guys think? The answer is yes, Storm. And can you tell us why? You're absolutely right.
Well, I just had it. It's on the tip of my tongue, like the tip of my tongue phenomenon. But I can't right now.
I got you. All right. Look, I'm saying I'm 95% sure the mean is in here. Is 28 like way outside this? You guys notice how 28 is way outside the interval? And since 28 is outside the interval, that we're saying, look, we're 95% sure the real mean is between here, which is way less than 28, which is way less than 28. 28 is like way outside the upper bound. And it's like, yes, it does support the claim. Because 28 is outside the interval. And we're going to get an opportunity to do more of these examples next class, I promise you. But before I leave you guys, leave everybody, is at least using the calculator pretty straightforward for constructing these intervals? Well, I hope so. Okay. All right, so what I'm going to do is I'm going to, let me stop the recording.